Hi everyone. Today we're going to study standard normal distribution and z-scores. Let us begin with normal distribution. Most of the continuous random variables, such as heights of adult men or women, have distributions that are bell-shaped. And these are called approximately normally distributed variables. Normal distribution is presented by the normal curve. This is the normal curve. The normal distribution have characteristics. Number 1, it is symmetric about the mean. Since it is bell-shaped, this vertical line at the center is where the mean is located, and there is symmetry about the mean. Number 2, unimodal. There is only one mode. We define the mode as the value with highest frequency, and from this graph, the highest peak corresponds to highest frequency. So the mode is also located at the center. Number 3, the mean, median, and mode are equal and located at the center of the distribution. So we placed already the mean and the mode at the center. We will add the median. These values are equal and located at the center. Number 4, the curve is continuous, that is, there are no gaps or holes. Number 5, the curve never touches the x-axis. Number 6, the total area under the normal distribution curve is equal to 1 or 100%. Here now is the standard normal distribution. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. This is an example of a standard normal distribution. The mean is at the center with value 0, and the numbers going to the right are 1, 2, 3 respectively, while on the left we have -1, -2, -3. Take note that the interval between two numbers here is equal to the standard deviation. Normal distributions can be transformed to standard normal distributions by the formula z equals capital X minus mu all over sigma. The z is the z-score. The capital X is a score in normal distribution. Mu is the mean of normal distribution, and sigma is the standard deviation of the distribution. The standard normal distribution is sometimes called the z distribution. Let us have this example. Here is a normal distribution. The mean is at the center at 1010. Sigma, or the standard deviation, equals 20. In here, the interval of the numbers are measured by the standard deviation. The center at 1010, the next number is 1030. The next is 1050. and the last is 1070. The same pattern follows on the left side. On the left of the mean is 990. Next is 970, and the last number here is 950. So we can observe that the interval is of this value, which is the standard deviation 20. We can transform this normal distribution into standardized normal distribution. The mean will be equal to 0, and all these numbers will correspond to z value into 1, 2, 3 respectively. And on the left side, -1, -2, and -3. Let us see this example. Find the z-scores for the following x values given that mu, or the mean, equals 40 and sigma, or standard deviation, equals 5. Letter A, 48. B, 40. C, 30. Let us now write the formula of the z, that is capital X minus mu over sigma. Let's begin with problem A. X equals 48. So we have here z equals that 48, we write here, minus the mu is 40 over the sigma 5. Simplifying this, 48 minus 40 becomes 8, and this is divided by 5, so we have 1.6. Next is letter B, that value 40. So we have z equals 40 minus 40 divided by 5. 40 minus 40 is 0, divided by 5 is simply 0. Letter C is 30. So the z equals 30 minus 40 all over 5. The difference on the numerator is -10, divided by 5 is -2. So these values of z, we're going to write to each of the problems here correspondingly. Here we go. Now, let us show the z value in a standard normal distribution. We have the mean as 40 corresponding to 0 in the standard normal distribution. So let us begin with letter A. The z equals 1.6 for the x value 48. So here is the 1.6 and the 48 is here. So 48 is on the right of the mean. Letter B is 40. So the z equals 0. So the x value 40 is the same value with the mean. So the z equals 0. Next, letter C, z equals -2. -2 is here. So that is where the value 30 lies. With the figure here and with this example, we can deduce some conclusions. So let us remember, when z-score is positive, the x value is above the mean, just like with the number 48. When z-score is negative, the x value is below the mean. And this is reflected by our example when x equals 30, corresponding to z-score as -2. While when z-score is 0, the x value is equal to the mean, just like our example x equals 40. Hi everyone. Today we're going to study area under the normal curve. The area under the normal distribution curve is used to solve practical application problems. Here are two examples. 1. Finding the percentage of teenagers whose weights is between 40 kilograms and 65 kilograms. Second example, finding the probability that a new battery will last longer than 4 years. This is the table for the area under the normal curve. In here, entries in the table give the area under the curve between the mean and z standard deviations above the mean. For example, for z equals 1.25, the area under the curve between the mean, which is 0, and z is 0.3944. In looking for that area of z equals 1.25, first, let us consider the first column. Let us look for the 1.2 value, and it's here. And then, on top is our first row that we need to look for the 0.05. The intersection of these two numbers is the 0.3944, and this is the area. There are 7 basic types of problems in finding area under the normal curve. Case 1 is between 0 and any z value, as shown in these two figures. In here, we can simply look up the z value in the table to get the area. Case 2 is if the area required is in any tail, as shown in these two figures. We look up the z value to get the area and subtract the area from 0.5. Case 3, between two z values on the same side of the mean, as we can see in these two figures. Letter A, look up both z values to get the areas. Next, subtract the smaller area from the larger area. Case 4, between two z values on opposite sides of the mean, as we can see in this figure. Look up both z values to get the areas, and then we add the areas. Case 5, to the left of any z value where z is greater than the mean, as we can see here. We look up the z value to get the area, then add 0.5 to the area. Case 6, to the right of any z value where z is less than the mean, as shown in this figure. We look up the z value in the table to get the area, then add 0.5 to the area. Case 7, in any two tails, as we can see here. Look up the z values in the table to get the areas. Subtract both areas from 0.5. And the last, we add the answers. Here is the procedure in finding the area. Number 1, we draw the normal curve. Second, shade the area desired. Number 3, find the value in the area under the normal curve table. Number 4, solve for the area as required. Let us see example 1. Find the area between z equals 0 and z equals 1.97. Let us draw the normal curve, and here we have the normal curve. Let us shade the area desired. Z equals 0 is the mean, which is at the center, and z equals 1.97. This value, being positive, must be on the right side of the mean. Let us shade the area from 0 to 1.97. Here we go. Number 3, find the value in the area under the normal curve table. From the table, when z equals 1.97, the area is 0.4756. The step 4 is to solve for the area as required. This problem is in case 1, so the required area is that same area from step 3. This is the final answer. Example 2. Find the area between z equals negative 2.10 and z equals 0.53. Drawing the normal curve, we have here the curve, and let us shade the area desired. The z, negative 2.10, is placed on the left side, while the z, 0.53, is positive, so it must be on the right side of the mean, respectively. Then, let us shade the area between z equals negative 2.10 up to z equals 0.53. Let us find the value in the area under the normal curve. When z equals 0.53, the area is 0.2019. When z equals negative 2.10, we can use the absolute value 2.10, and the area is 0.4821. Then number 4, solve for the area as required. We can see here that this is about case 4, and we need to add the areas. The sum is 0.6840. This is the total area. This is the final answer. Today we're going to study normal distribution curve as a probability curve. The normal distribution curve can be used as a probability distribution curve for normally distributed variables. The area under the curve is more important than the frequencies, and it corresponds to a probability. Let us see the proportion of areas under the normal curve. The area contained within one standard deviation from the mean is 68%. Thus, from negative 1 to positive 1, that is the 68% of the area. The area contained within 2 standard deviations from the mean is 95%. It means from -2 up to +2, that is the 95% of the area. The area contained within 3 standard deviations from the mean is 99.7%. From this -3 up to +3, that is the 99.7% of the area. Let us see this example. Find the probability that Z is between 0 and 1.32. Let us draw the curve, and let us identify the endpoints of the Z value, and this is from 0 up to 1.32. We can see that this is a positive value, so we placed it on the right side of 0 or of the mean. And let us shade the required area, so here we go. Then look the area in the table, and that is 0.4066. We write this answer in here, and this is the final answer. This is the area that we want. And this is the probability that Z is between 0 and 1.32. Example 2. Find the probability that Z is greater than 1.65. Let us draw the curve and identify the location of 1.65. It is a positive value, so we place it on the right of 0, and it's here. And then let us shade the required area, and it corresponds to the right tail of the curve. Now let us look for the area for Z equals 1.65 in the table. And that value is here, 0.4505. We copy this value in here, and then we note that this area described from 0 up to 1.65. But we want the right tail area. Also, we say that half of the curve has area of 50%. So the probability of Z greater than 1.65, we subtract this area from 0.5, and the difference is 0.0495. This is the area of this right tail, and this is the probability. Example 3. The speed of transfer from a server on a campus to a personal computer at a student's home on a weekday evening is normally distributed with a mean of 60 kilobits per second and standard deviation of 10 kilobits per second. Find the probability that the file will transfer at a speed of less than 70 kilobits per second. For step 1, we're going to convert this 70 to Z score. We use the formula Z equals capital X, that is the value 70, minus mu, which is the mean, over sigma, and this is the standard deviation. Substituting the corresponding values, we have 70 minus 60 all over 10. 70 minus 60 is 10, and we divide this by 10, z equals 1. For step 2, we will draw the curve and shade the required area. By the way, this problem less than 70 correspond to the probability that z is less than 1. Drawing the normal curve now, and let us identify the z which is 1, and it's here. When we say z is less than 1, we mean that the other half of the curve is included. Step 3, find the area of z equals 1. In the table, that value is 0.3414. We copy this value in our step 3 answer here. But take note that this area described from 0 to 1 only. This is the described area. So what we are going to do is to add 0.5 to this area. Now the sum is 0.8414. This is the desired area, and this is the probability. I hope you learned something from this video. See you again next time.